Assalamualaikum and good morning to Dr. Mazdida and everyone. So my name is Hartini binti Abdul Rauf with metric number 23006157. Today we would like to present our assignment of SIC 1001 molecule building and analysis. So we choose a compound of formaldehyde CH2O. You can see from the slide that is the structure of formaldehyde. So there is a chemical bonding present between each of the atom. The type of chemical bonding present in formaldehyde is covalent bond. For carbon and hydrogen bonds, each atom of hydrogen shares one electron with carbon atom. It forms two single covalent bonds between carbon and each of hydrogen atom. So by sharing electron, it allows both carbon and hydrogen achieve stability. So for C double bond O bonds, carbon atoms shares two pairs electron with oxygen atom and form double covalent bond that consists two shared pairs electron resulting stronger bond. So it allows carbon and oxygen achieve stability. So we move on to the atomic structure and electronic configuration. For carbon, it has a 6 atomic number and form electronic configuration 1s2, 2s2 and 2p2. So from the electronic configuration, we can identify the valence electron by looking at the outermost shell, which is the second shell. So the valence electron are in the 2s and 2p sublevels. Therefore, carbon has 4 valence electron, which is 2 from 2s2 and 2 from 2p2. So for hydrogen, it has a 1 atomic number and form electronic configuration 1s1. So the valence electron are in the 1s sublevels. Therefore, hydrogen has 1 valence electron, which is 1 from 2s1. So for oxygen, it has a 8 atomic number and form electronic configuration 1s2, 2s2 and 2p4. So the valence electron are in the 2s and 2p sublevels. Therefore, oxygen has 6 valence electron, which is 2 from 2s2 and 4 from 2p4. So for the relationship to periodic table, as you can see from the periodic table, carbon is in group 14, period 2, and hydrogen is in group 1, period 1, while oxygen is in group 16, period 2. So the period of an element is determined by its principal energy level or highest energy level that contains electron. For example, element carbon with its electronic configuration 1s2, 2s2, 2p2, the outermost shell is the second shell, which is principal energy level 2. Therefore, carbon is in period 2. Same goes to identifying the period of hydrogen and oxygen. While the group of an element is determined by its number of valence electron, the group number is often equal to number of valence electron, except for the transition metals. The group may not directly correspond to number of valence electron. So for example, element of oxygen with its electronic configuration 1s2, 2s2, 2p4. So oxygen has 6 valence electron, 2 from 2s2 and 4 from 2p4. Therefore, oxygen is in group 16 because it has 6 valence electron. We adding up 10 to identify its group. So from hydrogen to oxygen, the number of valence electron increase. Same goes to its group. From hydrogen to oxygen, the number of energy levels increase. So that is all from me. Thank you.
Hi, I'm Teo Hong Heng. My metric ID is S2138528. I'm here to talk about the molecular geometry for CH2O. As you can see over here, the top left side, it is what we call CH2O. So this is the structure of the CH2O. The center is carbon, okay, where it is attached to oxygen and 2 hydrogen atoms. Okay, so there is a difference in the electronegativity between the carbon and oxygen atom, which is causing the dipole moment. I'll talk about this one later. CH2O is also known as formaldehyde, okay? It is forming a trigonal planar shape. Alright, so this is the simulation that we have done. This is the canonical orbital simulation. So the top left side is showing alpha HOMO figure, alright, and the bottom right side is showing alpha LUMO figure. So what is HOMO and LUMO representing? HOMO representing highest occupied molecular orbitals and LUMO representing lowest unoccupied molecular orbitals. It is actually where the electrons being distributed. It is actually an area there, the area that is occupied. So let's look at the next one, okay, which is the reactivity. So the position of the electron that is being distributed, okay, it is actually affecting the reactivity. So the value for alpha and beta determines the oxidation and reduction, okay, of the molecule. So alpha and beta affects the reactivity of the molecules. Lobe of the LUMO can predict addition to pi ligands. So as you can see over here, this is the dipole moment for the CH2O. So there are different combination between X, Y, and Z axis. So we use P to represent the dipole moment, and we can solve for the Schrödinger equation. So Schrödinger equation is given by negative h bar square over 2m Laplace operator square phi plus V phi is equal to E phi. So what we want to know over here is actually the E, the energy. So energy help us to study the reactivity for the CH2O. Thank you.
Hi, I'm Nushafiza binti Fazil. My matrix number is 22002722. I would like to continue our group presentation regarding real-world application of formaldehyde. It is mainly divided into three parts which involve automotive, building and construction, and health and hygiene. Let's move on to the first part, which is automotive. First of all, formaldehyde is used for adhesive for bonding parts. For example, formaldehyde-based adhesive have been used in bonding various parts of a vehicle during manufacturing, ensuring structural integrity and durability. Next, formaldehyde is used for interior components. For instance, formaldehyde resins have been employed in creating interior components like upholstery, headliners, and composite materials used in the construction of certain vehicle interiors. Lastly, formaldehyde is also used for surface coatings. As an example, formaldehyde-based coatings or finishes were utilized in some instances to provide protective layers or finishes on certain automotive parts or components, contributing to their durability and longevity. Now, let's look at the second part, which is building and construction. The first application that I'm going to highlight here is formaldehyde is used for composite wood products. For example, formaldehyde resins are commonly used in the production of composite wood products like particle board, plywood, and medium density fiberboard used in construction for flooring, cabinetry, furniture, and structural components. Secondly, formaldehyde is also useful as insulation material. To illustrate, some insulation materials, particularly certain foam insulations, may contain formaldehyde-based resins as a binding agent or in their production process. The last one is adhesive and sealants. For instance, formaldehyde-based adhesives and sealants have been used in various construction applications, such as bonding materials together or sealing joints and gaps in buildings. However, there's been a shift towards alternatives due to concerns about formaldehyde emissions and its impact on indoor air quality. Next, the last part of the real-world application of formaldehyde is health and hygiene. Firstly, formaldehyde has been used as disinfectants and antiseptics. As what we can see, formaldehyde-based solutions are used in some disinfectants and antiseptics, particularly in medical settings for sterilizing medical equipment and surface. Besides that, it is also useful as preservation of biological specimens. This is mainly seen in laboratories and healthcare facilities. Formaldehyde is used in solutions such as formalin to preserve biological specimens for research, teaching, and diagnostic purposes. Finally, formaldehyde is used in personal care products. For example, formaldehyde or formaldehyde-releasing agents were historically used in some personal care products like certain shampoos, lotions, and cosmetics as preservatives. However, due to concerns about its safety, its use in this product have significantly decreased or been replaced with alternative preservatives.
So for the industrial use, okay, I believe my friend really briefly explained about the resin products such as plywood and fiberboard. Right, let us move to the next one, which is the drug testing. Okay, so there is one reagent which is known as Marquis reagent. So this reagent can identify the alkaloids, right? So another use, okay, which is used in the disinfectants, okay, and also for preventing the growth of microorganisms. All right, so let's move to for a researching area. Okay, it is used in agrochemicals. So one of the use is as a fertilizer production, used in preserving plant and soil sample in the lab. Okay, also for the microbial control. Okay, there is also another deep research, okay, which is cross-linking protein. So this is more to the biology and chemistry, right? We also use it in the protein-protein interaction studies. It helps to stabilize the protein complexes, okay? So this cross-linking protein, it helps us to study the different proteins. And that's all. Thank you so much.